had a funny incident last night. I went back to the hotel, and then, went for my room, put in the room card, and nothing happened. I said, did I forget my room number? Tried out a few other rooms, and it was completely weird. What is going on? So I went down to the reception and said, either the card is broken or forgot my room number. She said, let me see your card. No, you're in the wrong hotel. Go down, your one is down the street, there's one further down. I said, okay. So it's not even finished, the story. Then I went to the other hotel. I said, wow, it looks really similar. And I met a friend of mine, right, I haven't seen for a while. I just told her the story. You know what happened to me? So we went up to the second floor, and we said goodbye. And then she went to her room. Well, she went to my room and put her room card in the room, on my room door. I said, and then she was in the wrong hotel. And she was in the one I was before. So that's the Hampton and the Holiday Inn. That was really funny. Yeah. Okay. Deep dive into the Gradle-based Android build system. I'm Hans Doctor. I'm the founder of Gradle and the CEO of Gradle Inc. And I want to talk about the Android build system, right? The deep concepts behind the Android build system and why it is created that way. And yeah, let's start. So what are the goals of the Gradle Android-based build system? I think it is very important to understand as an educated Android developer what are the qualities, what are the deeper design goals of that build system. Even if you use it from Android Studio, right, and it's still I think important to understand. And also when you compare it with other platforms. And it's also interesting to see how we are actually doing in reality in regard to our lofty goals, right, or not so lofty, we'll see. So the first thing to understand, Android is a complex platform, right? Not quite as complex as C++, but way more complex than Java, right? So when you look at this diagram, even if you can't read what is in there, this is the workflow of building an Android application, right? So you have, and you all know that you have complex resource and code generation, right? You don't have that in Java. You have multiple different languages, right? You have the NDK, you have Java, you have the interface definition languages, and so so there's a lot going on. You have the signing, you have the dexing, plus the compiling, and so on and so on. So the original Java tools that were used to build Android apps are not made for that complexity. There was Ant, there was Eclipse, and there was, for quite a few people, Maven, right? So they're already hitting the limit in Java land, and they were not made for Android. And I talked about it, render script and native code and whatnot, but there is another challenge in Android land. I call it platform diversity, others call it fragmentation. And this has been one of the biggest pain points for developers to deal with, right? I just want to have a little variation of my app for that platform, right? And that was very hard to implement with the current builds, with the build system at that time. So how to make this diversity approachable from a developer tooling perspective was a key goal for the new build system. Okay, I forgot my transitions. Okay, here we go. So what makes Gradle unique and what is harnessed by the Gradle Android plugin is that you have the expressiveness to model the complexity, right? That you have really concise descriptions of your build. That's something Maven, to some degree, was doing a reasonable job in Java land. So that is a strength of Gradle. At the same time, Maven is concise for simple use cases, but can't go beyond that. And, or other similar kind of design systems like a Facebook bug or whatnot, they are very flexible, but they expose a level of complexity to developers and build masters that is, at one point, very expensive to manage, right? So, and Gradle tries to combine the conciseness of a declarative build language like Maven, right, without sacrificing the power and the flexibility and the extendability that you have with Ant and Ivy. In fact, done right, if you combine it, you get even better extensibility, and I will talk about that later. Okay, so to give you an example, what I mean with conciseness, right? Look at this very simple build definition for a standalone Android app. A few lines of code, you have two product flavors, right? Two dimensions, and for each dimensions you have two flavors, right? For the version, you have a free and a paid version, and for the ABI, you have ARM and x86, right? So, you could now do certain definitions. What you can already do when you have such a definition, you can put code in source free, or tests in source free, or in source paid, or in source ARM, or source 86, and Android knows exactly, the Android build system, what to do with that, right? It runs the free test only when you build the free APK, and so on and so on. So it is a reasonably simple problem, right? And this is how it is expressed. So, can you read that in the last row? No, I'm joking. So, when you do, for this little build script, right, when you do Gradle tasks, right, so all the tasks that Gradle creates to build this, right, you have more than 300 tasks, right? So imagine how the end build would look like, right? Would be 1,000 lines of XML, right? With Maven, on the other hand, it's completely impossible to model this within one project. Maven would tell you, well, you need a separate sub-project per flavor, per test per flavor. You would end up with a sub-project 30 multi-module Maven build or something like that, right? Which is also kind of, you know, hey, I'm an Android developer, I have a little requirement, certain variants, right? I want to express around my simple Android app, and now I end up with a 20, 30 sub-module Maven build. That's not what you want to be challenged with as an Android developer. So that gives you kind of an idea, right, what has been achieved. So a key mission is accomplished, right? There's now a powerful Android build system with which you can elegantly describe many of the typical requirements you have when building Android applications, including kick-ass dependency management, right? It has the right mixture between flexibility and structure, right? Too much, when you just have flexibility, you might have a lot of complexity to deal with as an Android developer. But if you have just structure, no flexibility, you can't extend the thing. So this is a real nice mixture, and it's a true achievement by the Google Android team, who is maintaining and creating the Gradle Android plugin, to have modeled the functional domain of building Android so well. Based, of course, on the capabilities of Gradle, but and there's more to come. So the foundation is rock solid. And the feedback we are getting is that people are very happy with that aspect, right? And I haven't talked about performance yet. And I want to talk about something else first. Some other goals that are behind this system. It is not good enough for most Android developers to just have a good Android build, right? You have backend services, right? Written in Java, C++, Ruby, and whatnot. You have other libraries to deal with, and potentially written in other languages. And you want to be able to integrate deeply with those during development cycles, right? You don't want to be the isolated Android team like it is still today in so many organizations, right? The Android teams are isolated from the continuous delivery process of the rest of the team, and that is not good, right? The people writing the backend services should be able to ask the question, is this change breaking the Android app, right? And that is often not possible, but with Gradle, you know, I have the tool to have a really unified build experience, right? And Gradle is a powerful polyglot build system, with strong support for C++ and Java, also for Python, and interesting wrapping around the JavaScript ecosystem. So LinkedIn is a very good example for that. LinkedIn has an armada of languages. It all builds with Gradle in one or the other way. 40 plus languages, some are very exotic, all built with Gradle, right? Either with a direct implementation or with Gradle, like with Python, adding some functionality on top of the existing Python toolchain, right? They've also integrated a Hadoop developer tooling around it. So that is a big benefit you get, right? If you work in a team if you're not just writing Android, right, you have now a build system that can integrate all the different pieces much better. To give you an idea of the scope, how Gradle is used in some organizations, at LinkedIn, it is used by 2,000 engineers, and they have 300,000 Gradle build executions per week, right? So the biggest Gradle build has 3,800 submodules, and one other thing that is interesting with LinkedIn, like more and more organizations, they switch from teams that have been created around technology, the Android team, the iOS team, to functional teams, right? So teams that share the backend and the different UIs and apps that are developed around a set of functionality. So now for them, it's even much more important to have a build system that wraps around the whole functional team, right? Even though they're using very different languages. Okay, before I talk about performance, extensibility. It is not just good enough to solve the standard requirements, even in a polyglot setting, right? So you get a lot of out-of-the-box stuff from Gradle, so the example projects all work, right? But people that are ambitious about developer productivity and automation and or work in a more complex environment desperately need extensibility, right? So with the new build system, you are able to inject custom steps anywhere, right? You have deep APIs with listener frameworks to get into the guts of the system if needed. Even in a test execution, you can hook in a listener with Gradle. Hey, send me an event after you've executed a test method. I want to do something with it, whatever that may be, right? Maybe you have a fragile test you want to deal with, and you say, oh, this test I need to run again to make sure that it has really failed. Whatnot, whatever pathologies you need to embrace, right, as part of your work. And there are powerful features to integrate deeply any other technology toolchain into your build, right? So, and it's not just extensible. You can extend it in a way that your build stays concise, right? You can extend the Gradle declarative language with your own declarative language element to make it very easy for your developers to work with your custom requirements. And even if you say, oh, extensibility is not important for me, well, in an indirect way, it is, because you will benefit from it by a very powerful plugin ecosystem that depends on this extensibility, right? And there are really interesting Android plugins out there. If Gradle weren't so extensible, the plugins wouldn't be so powerful. So even if you don't extend it, you have a more powerful plugin ecosystem out there of Gradle plugins that you can use. I always forget my transitions. Anyhow. Okay. So Gradle is a very strong foundation for the Android build system. It is a build platform, with massive tractions. We had just crossed the 1 million downloads per month line in September. It's evolving very fast. We had 19 feature releases in the last 3 years. And we get a large amounts of contributions from individuals and organizations like LinkedIn, Netflix, Google Android, Unity Technologies, and many more. So a lot of innovation is happening, and Gradle is a generic automation platform, right? For whatever you want to automate, you can use it. Because you as a developer, you're not just creating APKs. You are shipping software with a group of people, which is a much larger scope, right? You might want to have auto-provisioned dev environments. You might want to generate documentation for a client API that you are shipping, where all code snippets are integration tested. That's how we ship our documentation. Every snippet in the Gradle user guide is live tested. We run while we're creating the user guide, we run the integration test, right, against the snippet in there. Then we extract the output of the integration test and insert it into the user guide to make sure that we don't have the money for an editorial team or don't want to spend it on that, right, and still want to give you high quality documentation, right? So when you really think about shipping software, there are so many tasks you can automate, right? And once you have a system that allows you to do that, you can get really creative, right? You want to have a fully automated release process. You might want to have central version strategies for the libraries you're consuming, automated database migrations, container integration for certain integration tests, right? How to deal with fragile tests, big problem we see in many organizations, right? When you have a build system that says, well, you can only have one group of tests, right? when some of them are fragile tests, it usually means people start ignoring if this test suite fails. They say, yeah, okay, might be interesting that it fails, might be not. So with Gradle, you could easily isolate to say, okay, they are non-fragile tests, I put in that group, right? And they are really part of my continuous delivery pipeline. If the CI is failing here, everyone stop work and fix it. And then there's the other group of tests, they're fragile. The manual testers might still use them to get some indications, but I don't want to rely on them for my automated pipeline, right? Stuff like this. Or you have very time-consuming pseudo-integration tests, right? Where you want to maybe separate them into DB integration tests, UI integration tests, so that you get faster feedback. People that work on a database only want to execute the DB integration tests before they commit because they don't want to wait another hour, right? So there is a lot of interesting stuff in the domain of continuous delivery. It's a complex domain. Gradle is your friend, and so be ambitious about automating your whole shipping process. So let's look at an example of some of the nice features that how Gradle can help you in getting better into the flow and achieving a higher degree of automation. So this is what we have here is is an ASCII Doctor project. So let's look at this. So it's built with Gradle. Who of you knows ASCII Doctor? ASCII Doctor is a markup language, more complex than Markdown. It's kind of replacing the doc books and the latest of the world. So O'Reilly is using ASCII Doctor only since a couple of years, I think, for their books. And so there's a Gradle ASCII Doctor plugin out there. Let's look at that project, right? We have a source main Java directory, so it's a Java project, and with ASCII Doctor we create a manual for that. Can you see that, by the way? Okay. We create a manual for this Java library, right? And example-manual is the source file for the manual. Okay, so let's look at the source file. So here you see the ASCII Doctor annotate or markup language, and we can now tell Gradle, hey, turn this into a HTML page. Right? So we did that. Now we open the HTML page, and you see this ASCII Doctor document now rendered in HTML. Okay. All right. So let's change the source file, the ASCII Doctor file. Let's do something exciting. We go back to the command line. We build it again. We refresh. I don't expect you to be excited yet. So now we do something exciting. We run the ASCII Doctor task in the Gradle continuous mode, -- continuous. And what you can see now Gradle listens. Now Gradle listens to any changes, right? So if we now go back to the document, let's do something really exciting. And we save it. We don't need to rebuild. We just do a refresh, and it's updated, right? And yeah, and of course, we can continue to do that. Continuous mode introduced with Gradle 2.5, and we are super excited about that. So we save it again. We do a refresh, and here we go. And you can now see that the changes were detected, so the builds were executed, and the interesting thing, I mean, it's not the first time that there is a watch solution on the market. You have that, you have for people doing Ruby, they had that and whatnot. The special thing here is you don't need to specify anything. You don't, usually all these watch solutions, you need to specify some glob patterns, where to look for, and what to do if that pattern changes. Gradle knows all that. We have a rich input-output model. You just say, run this task in continuous mode, and Gradle knows exactly for what changes to look, because the input and outputs are defined in the Gradle build. That makes sense. So for developer, it's super easy, right? You can do this with any Gradle task. They don't need to configure anything for this, right? And so we use that in many places internally, right? Documentation is a place. Another place is for our upcoming Gradle.com offering, right? Our whole backend app, right, is using that continuous mode. We started in continuous mode, and then whatever we change in the app, right, it's automatically picked up. The app is redeployed, and it's a wonderful, rapid application development mode. And think about what that means from a deeper point of view. So we had a chat with LinkedIn yesterday, and their goal for next year is that the developers never need to directly call the build system. That is the goal for 2016. So how they are going to achieve that? That is a key tool for that. So they basically will bundle a pre-configured continuous mode settings with their IDE, right? So when the developers fire up the IDE, they not just fire up JetBrains and IntelliJ, they fire up a whole set of rules that Gradle gets instructed with what to watch for, right? So when you have some source code generation, some specific one, right? You just fire up the IDE, it starts the continuous mode, and your developers do some changes in, let's say, the XML configuration file, and boom, Gradle will automatically rebuild it. The developers don't even know, is that the IDE doing this? Is that the build system doing that? Well, and the whole thing is the IDE, right? It's the whole thing. And so I'm super excited about how continuous mode can basically extend the capabilities of a classic IDE, because finally your IDE becomes extendable with Gradle, right? Who of you has ever written an Eclipse Nature or an Eclipse Builder? Who wants to do that, right? Yeah, so, and IntelliJ is the same thing. Build systems are made for this kind of stuff. So continuous mode is a super exciting capability. And I'm sure we will find interesting opportunities to integrate that with Android Studio. So we already had a chat with the guys, and we will see what comes out of that. Okay. Talking about Android Studio, one of the most important goals of the new Android developer toolchain was a true Android IDE that natively understands Android projects, right? In contrast to, let's say, the Eclipse ADT project, right? And the other key goal was the IDE should build the same way as the command line and CI, right? That you have consistency and coherent quality of service of the dev tooling. If you remember, Eclipse ADT had a separate build system, right? You had an Ant build or Maven build, whatever you have chosen, right? But when you were working in Eclipse ADT, it came with its own toolchain, own merging, own everything, right? That's how you had to do it, right? There was no way to deeply integrate it. So the goal of Android Studio was the IDE is not doing any actions themselves anymore, right? Every action, execute, test, generate resources is delegated to the underlying Gradle build. So that whether you execute your build from the command line or whether you just work in Android Studio, it's exactly the same behavior. And so unified build system, and I talked about with Gradle you can now extend your build system, right? You could easily, right? Let's say you're working in Android Studio on some widget that shows you a quote of the day, right? So you could now, let's say, if it's just for fun for your developers, you just use it for the debug build type, right? And you could now easily tell Gradle, hey, I want to hook in another task while you are generating the resources, and I want you to retrieve the quote of the day from some server and add it to the resources files, right? So you just add that task to your build script, and if you're working in Android Studio, because Android Studio instructs Gradle to create the resources, you will now have in your visual design widget, you will have always a changing quote of the day, right? So you get the point, right? It's now fully integrated with Android Studio because Android Studio is delegating everything to Gradle. So you can now really powerfully extend your IDE. With Eclipse, ADT would have been completely impossible. Separate worlds, what you do in the build and what you do in your IDE, and your IDE is usually not extendable, right? So, and the other part besides being extension aware is as the Android domain is deeply modeled in Gradle, it is easy for Android Studio to derive rich information from the build spec, right? So if you look at an example, right? So here we are in Android Studio. So we have that, we have two product flavors, free and paid, right? They use different, for whatever reason, they use different version codes, they could use different dependencies, but that's not what I want to show here. And so now we go into the visual mode, right? And we can now change, I will have a stiff neck after this talk. You can now change, because I don't see that on my screen, the build variant, right? So we choose free release, and if we switch to paid debug, right? That is deep IDE integration, right? And that's fun. That's how it should be, right? So, okay. What do I want to show here? Yeah, I skipped the whole tooling API topic. So we have a special library that we create so that IDEs can interact with Gradle, right? Be it Android Studio, plain IntelliJ, or Eclipse. But don't need to go into the detail. The only thing that is interesting, that's the only thing I would like to mention. So we support, we ourselves create the Gradle plugin for Eclipse, or I should say, yeah, the Gradle plugin for the Eclipse plugin ecosystem, to be very clear. And we only do that for Java, right? We're not working on Android support for Eclipse. And one thing we have added that is really nice, I talked about how, what a deep API Gradle has. What you can now do from Eclipse is when you go to your package or to any test class, and you can right-click it, and you say execute. You know all the visual view you then get that shows you the test execution, right? The execution windows for tests within an IDE. Classically, the IDEs come with their own test runners, right? So now with BuildShip, you have now the same visual representation, a really nice runner, right, that runs the test, gives you a green or red button, but actually all the tests are executed by Gradle, and with the tooling API, we hook into the eventing system of Gradle and can have a really nice, rich representation. At the same time, it's no longer that the Eclipse has a separate test execution than Gradle. And think about it, what that means for integration tests. I've been in many organizations. They told the developers, if you want to execute the integration tests from your IDE, you have to go to the build wiki. And before you integrate your integration test, you have to go to the command line and execute with your Gradle and Maven build. Fire up database, create test data, some manual step, and then you can run the integration test from Eclipse, because you couldn't extend Eclipse to do this kind of stuff. Now with Gradle, all this test fixture setup is implemented in Gradle. So if you now can run your tests executed by Gradle from an IDE, you don't need to go to any build wiki. The developers don't care. They just say, run my test, and Gradle makes sure that all your test fixture is properly set up, right? Because it's extensible. Okay. So to wrap this up, I want to look a little bit under the hood of certain core concepts. So this is the plugin that tells Gradle, hey, this is an Android application, right? And we call that a declarative element. I will talk about that in a second, what we mean by that. So first of all, it constitutes certain conventions, right? If you tell Gradle this is an Android application, we say if you then put certain things at certain places, like like the source code and the tests, as defined by the conventions, you don't need to specify anything, right? And just by those few lines of code and sticking to the conventions, Gradle will provide you all the tasks that are necessary to deal with this application. So that's why what we define as a declarative element in a build script. A declarative element in a build script is something that specifies the what. This is an Android application. The how is automatically figured out for you by Gradle, right? We call this the executional units, right? That every build system has, right? You don't need to specify them directly. And is fully imperative, right? You as a build author or build as someone that specifies the build, with and you have to do all the specifications directly via the executional units, via the targets, right? With Gradle, you have declarative elements, and the executional units are derived, right? So, and then you can, run the assemble debug and whatnot. So the interesting thing, and this is where Gradle goes way beyond other declarative build systems, you have very fine-grained declarative elements. So build types, and you can specify a release type, or we have the product flavors where you can specify free and paid product flavors. And those are not simple this is not like simple configuration actions what you're doing here. You're really using new declarative elements. What do I mean with that? When you specify, I have a free product flavor, you trigger a whole little mini framework, right? When you specify the free flavor, Gradle will automatically create a number of tasks, right, to deal with this free flavor. Assemble, the free APK, all the resource generation, a test task that only executes the tests for the free flavor. You have a certain set of conventions in place. If you now put code in source free, it will be automatically picked up. So this is a very powerful element, right? So, and after adding the fact that you have a free flavor, right, you can see all the tasks that are automatically created as part of that. So for us, declarative elements are a very important concept to give you the right structure the right mixture between flexibility and structure. High-level declarative elements, right, that you can pick and choose to describe your requirements. And what is a key goal for us, that you can describe it with your domain language. We don't make you think like a build system. You can think like an Android developer specifying what you need, and we translate it into build system concepts. If you need to do some really deep customizations, yes, you need to understand the build system, right? But not for your normal work. Okay, finally, performance. So let's talk about the Gradle core performance, right? Unrelated to Android, just the Gradle performance as a build system, right? Gradle is a very fast build system, right? So if you look at Java and you execute let's say a 25 submodule Java build, you just say, hey, clean and grade me all the jars of that, right? That's and I think with the latest Gradle versions it will be under 2 seconds, right? You can do it in parallel. So with the latest Gradle versions it will be under 1 second, and if you do incremental mode, you know what I mean. So this is all. Gradle has and we always continue to work on that, right? This is now a 200 submodule build, right? And even that is, if you do a full clean build, is not strictly slow, right? See that? Boom. And again, we have improved that even since I did the recordings, right? So 7 seconds for 200 submodule builds with a lot of code is fine, right? And we are working with some very large software stacks, right? And they have extraordinary performance requirements, and our goal is to be the fastest build system in the world, right? And especially for those large teams to bring them finally into the agile land. When you have to wait for 1 hour until your build finishes, you can't do agile development, right? And the LinkedIn build time got down when we're migrating from End to Gradle from 5 hours to 30 to 40 minutes, right? It's still too long. We want to get it down under a minute. We want to get there with distributed builds and stuff like that. There's a lot of stuff we want to do. We want to be insanely fast even for very large projects. So, but the key message here is, but even if we had all those capabilities already in Gradle, that wouldn't remove the major bottlenecks with Android build performance that you are facing nowadays, right? So let's look at the Android toolchain. Oh, I want to show that later. So you have Android. It's good to be aware of those layers, right? You have the Gradle Java performance is very different from the Gradle Android performance. One reason is that the Java compiler is very fast, whereas the DEXing is not quite as fast. If the Java compiler were 10 times faster, and the Gradle builds were 10 times faster in Java, you shouldn't praise us. You should praise the Oracle Java C team, right? So we integrate with low-level toolchains, as is also the case with Android, right? So so if you have bottlenecks in the Android tooling, we don't maintain those tools. We can just use them, right? At the end of the day, I understand that you want fast builds, and that's what we will achieve more and more, but it's still important to understand that, right? So so you have the Android tooling, right, maintained by the Android platform team. You have the Gradle platform, maintained by us. You have the Gradle Android plugin, maintained by the Android tooling team, and you have Android Studio IDE, also maintained by the Android tooling team, right? Android Studio is usually never the source for any bottlenecks, right? It's the three layers below Android Studio that have been improved a lot, but we will continue to improve that you will have a very fast experience, but still it's interesting to understand that there are different layers, right? And all those teams, they're working closely together, right, to achieve that goal, right? And they're all doing a great job. And it's just that you can't solve everything at the same time. It was a lot of work to introduce the new system, right? It's a massive, including a new IDE. So certain optimizations will follow up later, and they're now all work in progress, right? So so let's talk about the Gradle, and by the way, this was just a tweet today from Gradle to 4.2.8. Incremental builds went down from 10 seconds to 5 seconds on one project, and 20 seconds to 11 seconds on another. So always remember to upgrade to the latest Gradle versions. There are a lot of improvements at the moment coming with every release, and we release every 4 to 6 weeks, right? And use the Gradle daemon if you're building from the command line. Otherwise, yeah. So, okay, let's not talk about that. So let's look at some numbers, how things have improved, right? So let's ignore 1, 2 to 1. So you see the big improvements we had for 10, let's say a 10 Android, pretty big Android build, 10 sub-projects, 10 variants per sub-project, right? We got the build time down significantly, right? This is now pretty extreme, one Android project with 400 variants, but you can see, so if you're not on Gradle to 4, right, that is the minimum you should be at, because that had dramatic performance improvements, right? So let's talk about the existing bottlenecks, right? So what I use as my guinea pig is the Google I/O Android app from 2014. It's on GitHub. It's open source, so it's a nice guinea pig. It is pretty representative. It has a bunch of open source libraries it's using and whatnot. So when you look where the time is going, if you do a clean install, right? At the end of the day, what you're interested in as a developer, you do some changes, and then you want to see the changes. Either you want to run your instrumented tests, which require an install, or you want to work with the deployed application on your virtual device, right? So you see the big bottlenecks are dexing and pre-dexing and installation, right? That is where, I don't know, 90% of the time is going, right? When you do a clean install, when you remove everything and you build again. So I want to talk a little bit about the pre-dexing. So the libraries your Android project depends on also need to be dexed, right? Not just your compiled source code. And this is done during the pre-dex step. And the Google Android plugin caches the DEX library so that the next time you run the build, DEXing will be much faster, right? But if you do a clean build, this cache is always deleted, and all the libraries you depend on needs to be pre-dexed again. And that's, if you look at this, pre-dexing, this takes the longest time, right? So clean builds are heavily penalized, if you like, right? Or first builds, because pre-dexing all the libraries you're using takes such a long time, right? And so we have some, what we want to do, right, over the next 3 to 6 months, right, is a couple of things, right? So first of all, the pre-dexing of your libraries is not happening in parallel, right? So when you have 15 libraries, one is dexed after the other. The other thing that is something we want to improve, we want to put your pre-dexed libraries into a cache that survives a clean, right? Sometimes you need to do a clean, and then when you always have to have the pre-dexing, it's a pain in the neck, right? So we want to basically put the pre-dexed libraries into our library cache that will survive a clean, right? So this kind of a cache that is much more long-lived. We want to use for those pre-dexed libraries. Of course, we have to store the version of the dexing toolchain so that if you upgrade to a new dex version, we don't want to use this cached version. So we need to have a reliability in there, but that is something we will work on. So that means the pre-dexing will become faster because we will parallelize it, and it will survive a clean. So you will have to do it much less often. So pre-dexing, that is how this is going to be addressed. And what we also are going to start working on next year is a distributed cache. This means, I talked about that we put the pre-dexed libraries into a cache on your local machine, that it survives a clean. The next step is to put it in a cache that can be shared with all your developers. So if one developer has already pre-dexed the library, damn, get it, don't do it again. Or if you see iBuild has already done that, get it, right? All those sources will feed the distributed cache, right, with build output, right? And then other members of the team don't need to rebuild it. Which means if you are not just the one people team, right? If you have 10, 50 people, or let's say even 10 people and a CI server, it means you will hardly ever have to wait for pre-dexing once this is implemented, right? So caching pre-dexed libraries across clean builds and parallelizing pre-dexing will cut the amount developers need to wait for pre-dexing by an order of magnitude, right? And so that's good news. Those are the things we want to do. So this is now the most common cycle. You don't do a clean build. You're in Android Studio, right? You say, hey, I did some changes, now reinstall to my device, right? Now the situation is like, and you only, let's say, changed a single class, right? Still, you have now no pre-dexing anymore, so it's twice as fast, but still 33 seconds. It's not paradise yet, right? So most time is spent now on dexing, and then the other big chunk is install, right? And we will continue to work on making the other bits, right? Before dexing, all the stuff Gradle needs to do before dexing, configuration time. This will get faster and faster. But obviously, even if we get all the other stuff down to 0, right? It's still 75% is still there. That is not, yeah, that needs to be addressed. So not requiring to do a pre-dex cuts the build time in half. So we as said, it's not dominated by dexing. And the problem we have at the moment is a couple of things. So first of all, dexing takes long, right? And it's also not proportional to the numbers of changes you did, right? Even if whether you change one file or 100 files, everything will always be redexed, your whole code base. So you have a non-incremental slow dexing right now, right? And there is stuff on the way to improve that, right? There's not much Gradle can do. nothing at all to make dexing faster, right? So the Google Android platform team is working on a new dexing compiler called Jack. Who has heard about Jack? Yeah, so I don't have any deep knowledge about Jack, right? I can only, had a look at the website, what they're doing. The idea is that it consolidates the source code compilation and dexing into one step, right? So no longer source bytecode, Dalvik bytecode, but directly from source to Dalvik bytecode. And Jack has already an experimental incremental option that you can use. So there's serious efforts happening, right? And incremental dexing plus faster pre-dexing will lead to dramatic improvements of developer time, right? So I think with a little bit more patience, I think you should, things will significantly improve when it comes to the performance of your development cycles. Okay, what else will the future bring? I talked about performance in detail, right? For us, this is at the moment one of our major R&D effort. And so, every Gradle release will be faster, and with the other changes I talked about, the specific Android bottlenecks, when they are gone, you will have extremely fast Android builds. So that day will come. There is already the new experimental Gradle Android plugin out there, right? It is based on what we call the new Gradle model, which has much faster configuration time, which will eventually give you parallel task execution. So it's still very experimental, but it's out there, it's open source, you can use it, right? So to see what the future will give you. And the benefits you have already in this new plugin are significant, right, performance-wise. So the new Android plugin, just the configuration time for 10 Android project with 10 variants, with the next generation Android plugin is already cut down by a factor 3 and more to come. So, okay, extensibility is already the very strength of the build platform, but especially Android is pushing our extensibility to a certain degree. We have the Gradle platform, we have the Gradle Android plugin, we have some Gradle plugin by some virtual testing provider in the cloud like Testroid, and then we have organizations that do their own extension. So when you have this kind of extension hierarchy, we now put you sometimes in a situation that you need to do some workarounds to get the configuration order right and stuff like that. So we want, even in this very complex extension scenarios, we want to provide you a more solid extension model. That's something we're working on, and even if you don't use it directly, you will benefit it from that the ecosystem can work better for you. The other big area we're working on is dependency management. So we want to support fully variant-aware dependency management, so that you can basically have Android libraries and Java libraries that are aware not just about their version, but also is this debug or release type library, right? For NDK, is it 64-bit, is it 32-bit? And to make that a first-class citizen when you do dependency resolution. That is exciting work. CC++ is a very important platform for us. We are partnering, for example, with Unity Technology, who are migrating the whole native stack towards Gradle. And the NDK support in the new experimental Android plugin will no longer be based on Make, but on a Gradle CC++ plugin, right? And we're very excited about that. So you will have a similar rich declarative language to describe your native build requirements. Who of you is doing any NDK work? Yeah, so that should be really nice. Okay, so last but not least, we are releasing a SaaS offering very soon that allows you to connect your local or CI builds, right? All your Gradle builds in your organization with our SaaS offering. And this service will help you with understanding why something is wrong with your build, or helps the developer to understand why the build is not happy with the code, why the tests are failing and things like that. So why is it working locally and why is CI failing, and those kind of questions. So Very excited about that. If you're interested, please sign up for the beta waitlist. And you should be, hopefully in November we can have a full GA of that product. If you want to learn more about how to work with Gradle for Android, there is now an excellent Udacity class online. It's a Udacity class we have created together with Google and Udacity. It's free if you don't take it as part of the Android Nano Decree. I think it's now over 10,000 people that have already signed up. It's an old screenshot. And Udacity is amazing. Who of you has ever taken Udacity class? Yeah, I think it's the best online class experience I ever had. And this class is really, really good. So might be interesting for you, might be interesting for some of your colleagues. It's really good. Perfect start into Gradle land. We offer our own trainings, right? If you want to get deeper into Gradle, right? We have introductory, intermediate classes, but also very advanced classes, all delivered by Gradle core engineers, by people that deeply understand the platform. Okay, that's it. Thank you. Any questions? Questions? Yes, please.
The classes, are they free or what?
No, the classes, our classes are not free. We're not Google. So, yeah. And the difference is they're instructor-led, right? So the Udacity class is a. So you can ask questions whenever you have. So you get a good teaching experience, but you can also ask the Gradle questions you always wanted to ask. Yes, please. So please, can you say it again?
Sorry. So I noticed from the pie chart that about 30% of the cost is doing the installation on the handset, and that's basically just copying over the file over USB from your computer over the handset.
Yep.
Is there any plan to basically, if your resources don't change, then just keep them on the handset and copy turn it over the version on the handset? Because most of our apps, while they're
Yes.
resources and assets.
It's a good point, understand it. Something you would need to ask the Android tooling team. It's beyond, it's a good point. So, but they, I would ask it on the Android dev list or something like that, what their plan, if there are any plans. Yes, please.
I know this is read the manual
Oh.
question, but since you're here.
Yeah, fair enough.
Say so you're saying, hey, for the convention, if you had your sources folder and you have this and this because you're in the Android plugin, you just know that. You know that because that's just the way it is.
Yes.
Is there a command line thing where you can say, I'm using this Gradle file and I run this command, it'll tell me, here's where the source folder should be, here's where this folder, that, and it'll print that out for me?
Not yet, but it will be coming, right? So it's a very good point, right? So just to understand you, and the consumers for that would be new developers you hire into your team, or yeah.
New developers, and also even me, I'm sitting there like,
Yeah.
man, where's, the resource is not RES, but Android uses
Yes.
RES, Java uses resources folder.
Yes.
in that area.
Yes, no, it's a good point. So that is, yes, we understand that use case, and we will provide something. So, but it's nothing. Don't read the manual. You won't find anything in it right now. I mean, you find other interesting stuff in there, but yeah. I mean, strictly speaking, right? Because it's such a rich model. I'm just saying, we should do that, right? But strictly speaking, I think it would take you, or someone that knows a little bit about Gradle, 1 hour to create a plugin that would print out that information on the console. So at least you could do something about it, right? Not that we shouldn't do it, right? So don't misunderstand that. But it's Gradle is so open and so rich that you don't need to create secret master knowledge to do that, right? You could do that in a pretty straightforward way, actually.
Yeah, well, I was thinking also the plugin says, this might be called source. Okay, everyone knows that's for source for Java.
Yeah, so you could.
There might be another folder called RES. Well, what's RES used for?
Yes. So what you could do, that is a nice thing with the rich model, right? You could ask the Gradle Android build with a Gradle plugin. Hey, what are your all those sources are represented by which object? You can say, hey, main sources object, please tell me what is the path to the Java files, what is the path to the resources files, because it's all in there. And then you can print it out, right? Because it's all richly modeled. And then, oh, hey, variant container, do you have some variants? Yeah, give me the variant objects. Hey, free variant, tell me where are the sources for the free variant, where are the resources, where are the integration tests. So I'm not even exaggerating. It would be 1 hour and it would be on a console, right? Because it's richly modeled within. It's not just, it's no magic properties. That's what we hate, right? We hate something, oh, it's just somehow made up and there's some magic property hard-coded in the build script. No, it's all changeable and accessible. But yeah, we should come with this out of the box. Pardon? I mean, my flight is going. No, I'm seriously thinking about it. Just thinking about my schedule. Might not have, because I need to go to the airport. Maybe, let's see. Maybe I hack it up on the way back in the plane, and we'll send you something. Seriously, we will see. Yeah, cool. Yes, please. Yes.
Be using 2.8 right now, which just came out.
Yes. Yeah, you should be yes. So, I mean, the big compatibility issues we had in the past, and to be fair, was when the Gradle Android plugin was 0 dot something. So they were deliberately, right, they were by design, said, hey, it was a long period until we got to 1.0 with the Gradle Android plugin, but in terms of the contract, it was okay to break, right? So, but since 1.0 is out, I think it's extremely compatible with because we are extremely backwards compatible, right? So there's so what they were doing before 1.0, they were always because we work closely together, right? They said, oh, to make this really good, we need a feature that is only in Gradle 2.0 or only in Gradle 2.1, right? And so therefore it didn't work. The next version of the Android plugin didn't work with an older version of Gradle until they have reached 1.0, where they now invest more into backwards compatibility, right? So, but that was the reason, right? Gradle itself is extremely backwards compatible. We have a massive test suite, 16,000 tests, right? And we run it every night against all different Java versions and against cross version of Gradle testing. So that's something that where people are usually very happy with. That is the only reason why we can release so often. If we would break people, imagine a team like LinkedIn with 2,000 engineers. If you break them 2 times a year, they say, well, thank you very much, right? Then they would stop upgrading, right? So that is, we can only have that speed if we have the quality in that respect. Yeah. Okay, enjoy the show. Thank you.